let's take a look at row echelon and reduced row echelon. Forms of matrices. Okay, so first let's see what the rules are for row echelon, and then let's see how we can interpret those. So for row echelon, the first thing that you need to have is rows of all zeros are below non-zero rows. And then the next thing that you need is that the leading entry of any row must be to the right of leading entries above it. Now, some books will say that row echelon, the leading entry needs to be a 1. Other books will save that for reduced row echelon, but you might as well make it a 1, so you can do that. Row echelon forms are not unique, but reduced row echelon forms are unique. So let's take a look at this matrix. So 1, 2, 3, 4, 0, 0, 1, 2, 0, 0, 0, 1, and 0, 0, 0, 0. This is in echelon form because, first of all, the row that has all zeros is at the bottom. It's below all of them. And then if you look at the leading entry in each row, so this is the leading entry of row 1, this is the leading entry of row 2, this is the leading entry of row 3. The leading entry is to the right of the row above it. And so row 1 starts in the first column, row 2 starts in the third column, and row 3 starts in the fourth column, and row 4 doesn't have any entries at all. Okay, so we know that to be reduced row echelon, the leading entries have to be 1s, so they are here. But in addition, for reduced row echelon, in any column that you have a leading entry, you should have zeros in all of the other rows. So this is not reduced row echelon because we have this 3 here. So I've got a 1 in the leading position in column 3, and so I should have zeros in all of the other rows in that column. So reduced row echelon, any column with a leading entry should have zeros in every row other than the one with the leading entry. And then you should also have that all leading entries should be 0. And I think that is it. So then you can use these row operations to get it into echelon form or reduced row echelon form. So for instance, if I wanted to get the matrix above into reduced row echelon form, I would need to get rid of that 3. And I would do that by taking -3 times row 2 and add that to row 1. So plus -3 row 2. So if I multiply row 2 by -3, I like to write them out on the side because I'm going to make a mistake if I don't do that. So if I multiply row 2 by -3 and I add that to row 1, I will get 1, 2, 0, and then -6 plus 4 is -2, and then 0, 0, 1, 2. Oh, and then I have another problem, 0, 0, 0, 1, and 0, 0, 0, 0. So I also have a leading 1 right here, and so I need to have zeros in these columns. So that's easy. This one is going to be plus -2 times row 3, and this will be plus 2 times row 3. And then that will get me 1, 2, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and 0, 0, 0, 0. Okay, so let's take a look at another example. So I want to put this in row echelon, reduced row echelon, and I want to locate the pivot columns. So the pivot columns are the columns that contain a leading entry, and those leading entries are called pivot positions. Now remember, row operations involve I can swap any rows, I can multiply a row by a constant, or I can add to one row another row multiplied by a constant. So I know that I would like to have a 1 in the top right if possible. So I am going to start by swapping the first and last rows. Let's see how many mistakes I make. I am terrible with arithmetic, and this is just calling out for me to make mistakes. So I just swapped the first and last rows. Now I want to get zeros. So 1 is a pivot position, and so I'd like to have zeros in all of the other rows underneath it. So I am going to multiply or add multiples of row 1 to the rows beneath it to get them to be zeros. So for row 2, I'm just going to add row 1, and I will add 2 times row 1 to this one. Now I'm going to write that out to the side, so 2 times row 1 equals 2, 8, 10, -18, -14. Okay, so row 1 is 1, 4, 5, -9, -7. And row 2 will be 0, and I'm adding row 1 plus row 2. So I get 2, 5 plus -1 is 4, -9 plus 3 is -6, -7 plus 1 is -6. Now I'm going to multiply row 1 by 2 and add it to row 3. So 2 plus -2 is 0, 8 plus -3 is 5, 10 plus 0 is 10, -18 plus 3 is -15, -14 plus -1 is -15, and then I get 0, -3, -6, 4, and 9. And then, because I see that I can, I'm going to divide this row by 2, I'm going to divide this row by 5. I just noticed as I was writing it that they were multiples. Alright, now let me check and make sure I didn't make a mistake here. Let's see. 4 plus negative 2 is positive 2, and that was a negative 3, and negative 3 plus 8 is a positive 5. I knew I would make a mistake somewhere, and so this would be a positive 1. Okay, so the similarity between those two rows showed me that I probably made a mistake somewhere. Now I can see these two rows are identical, so if I just subtracted row 2 from row 3, I would get all zeros, and since I'm going to have all zeros, I'll move it to the bottom. So I'll have 1, 4, 5, negative 9, negative 7, 0, 1, 2, negative 3, negative 3, 0, negative 3, negative 6, 4, and 9, and 0, 0, 0, 0, 0. Alright, let me double check this row. Did I do anything to it? Nope. That's just 0, negative 3, negative 6, 4, and 9. Okay. Alright, so now I have this is a pivot and this is a pivot. So I want to get rid of this negative 3 and I want to get rid of the 4 above it. So I will multiply, or I will add to the top row negative 4 times row 2, and I'll add to row 3 3 times row 2. Negative 4 times row 2 is 0, negative 4, negative 8, 12, and 12. And 3 times row 2 is 0, 3, 6, negative 9, negative 9. Alright, so that gets me uh, 1, 0, and 5 plus negative 8 is negative 3. Negative 9 plus 12 is 3. 12 plus negative 7 is 5. Leaving this one alone. This one becomes 0, 0. 6 plus negative 6 is 0. Negative 9 plus 4 is negative 5. Negative 9 plus 9 is 0. And then I have a row of all zeros. Okay, so now I have my next pivot is right here, and all I need to do is multiply or divide this one by negative 5. And then when you have a row that just has a single 1 in it, that's easy to know what it's going to do. If I multiply this one by negative 3 and add it to the first one, it just will get rid of this one. And if I multiply it by positive 3 and add, it'll just get rid of that one. So this is going to be plus negative 3 times row 3, and this will be plus 3 times row 3. And then I just checked that on my calculator, and I'm very surprised to see that in fact I do have it correct. So this is in reduced row echelon form. If I look at each row, it either starts with a 1 or it is all zeros. All zeros are at the bottom, and each row, a 1 that is a leading 1 is to the right of any leading 1 above it. There's nothing I can do to get a leading 1 in column 3, so it's not a pivot column. Columns 1, 2, and 4 are pivot columns.